Problem number 3. Methyl salicylate, commonly used for temporary relief of muscle or joint pain caused by strains and sprain, is usually prepared by heating salicylic acid with methanol. In a design experiment, 1.99 grams of salicylic acid is reacted with 14.23 grams of methanol. Determine the percentage yield if 1.37 grams of methyl salicylate is formed. To solve the problem, we need to identify which is the limiting reagent in order to calculate the mass of the product that could be produced. And that is by converting the given masses of the reactants into the mass of the product. The limiting reagent is salicylic acid based on these calculations. Why salicylic acid? Because to determine the limiting reagent, you simply need to compare the amount of the product produced by each reactant. And based on this calculation, the amount of product produced by salicylic acid is lower than the amount of product produced by methanol. Next, from the maximum amount of methyl salicylate produced, we need to convert it into grams using its molar mass. This is then considered as the theoretical yield. So 0.0144 mole of methyl salicylate multiplied by its molar mass will give you 2.18 grams of methyl salicylate. Then, we could now calculate the percentage yield with the given actual yield. So the percentage yield is equal to 1.37 grams divided by 2.18 grams times 100. That is equal to 62.8%. Did you know that technically in practice or field, the actual yield is always less than the theoretical yield? Here are the reasons. 1. Even when a reaction is 100% complete, there will be difficulties in recovering all the amount of the product from the medium of the reaction using different separation techniques. Second, there are numerous reactions which are complex in the sense that the products may react further among themselves or even with the reactant to form other products, thus reducing the yield of the first reaction. This is also known as side reactions. 3. The impurities in the reactants used in synthesizing the target product also contributes in lessening the amount of the product. And 4. Many reactions appear to stop before they reach the full completion of the reaction, thus giving a mixture of reactant and products. To enhance the skills that you have learned in this lesson, please answer activities 1, 2, and 3. Are you ready now to summarize our lesson? Please supply the needed terms to complete this paragraph. These are the answers. At this point, let's have a further appreciation of our lesson. Did you know that scientists consider the percentage yield to determine the efficiency of their methods in preparing for the vaccines like the ones needed to treat COVID-19? What do you think would happen if they will not consider the efficiency of the vaccine to respond on a particular virus, or if they will not consider the best materials and reagents that will yield a high amount? Please write your reaction on a separate sheet of paper. Did you learn something from the lesson? Please answer the following post-test. You have to choose the letter of the best answer. Number 1. This refers on the amount of product produced in a laboratory upon carrying a particular reaction. A. Limiting reactant. B. Theoretical yield. C. Percentage yield. Or D. Actual yield. The answer is letter D. Number 2, which of the following statements is incorrect? A. The value of actual yield must be determined in order for the percent yield to be calculated. B. The percent yield is the ratio of the actual yield to the theoretical yield. C. The actual yield is usually less than the theoretical yield since there are reactions that do not go to completion. D. The difference between actual and theoretical yield is caused by using insufficient limiting reagent. The answer is letter D. Number 3. In most chemical reactions, the amount of product obtained is blank. A. More than the theoretical yield. B. More than the percentage yield. C. Less than the theoretical yield. Or D. Equal to the theoretical yield. The answer is letter C. Number 4. The efficiency of a particular synthesis reaction can be evaluated using the A. Limiting reactant. B. Percentage yield. C. Stoichiometric coefficients. Or D. Molecular weight of product. The answer is letter B. Number 5. Which of the following statements is not a reason why the actual yield is less than the theoretical yield? A. Impure reactants used. B. Competing side reactions. C. Loss of product during purification. Or D. Conservation of mass. And the answer is letter D. That's all for today. Thank you and keep safe.